right, we're going to start up. I'm going to go over chapter 6 today. I put this up on the screen just so you can all see it. If you don't know, the school's having a health fair today between 10 and 2. And they said 35 different vendors. They usually give away free stuff. And if you make a donation to Coins for Caring, you get put in for some grand prize, which is, I don't know. But it's supposed to, they call it a night of fun or something like that. I don't know. I'm sure it is. All right. So if you're interested, it's going to be down in the comments. And the other reason I'm telling you that is it usually gets really busy between 10 and 2 down there. All right, just so you know that. All right. So we're going to go over, like I said. Oh, okay, I thought I signed in, but evidently I didn't. We're going to go over chapter 6 in our book today. In fact, we're going to go over chapter 6 in both classes. Mike's here, so now we can officially start class. So if you do follow along in the book, I'm on page 339. Again, I want to say one more time, excuse me, just so you're aware of this, we're going to go over chapter 6. We've already done the Joes program. We did that on Monday. We looked at a calculator program. All right, next week will be lab. All right, there is at least a chance, just so you're aware of this, okay, that 2 weeks from today, I may have to take off. I may have a family commitment that they're going to let me know when they can let me know. All right? And that's no joke because that's April Fool's Day. All right? But there's probably a good chance I won't be here. I'll just be gone for the day. All right? When you've got an 85-year-old mother and an 86-year-old father and they request your presence at something, you typically don't say no. All right? Okay. So, again, page 339, chapter 6, you can see this is a short chapter for this book. It's about 40 pages long. In other words, we should be able to get done with this pretty close to at break time. All right, even going through it into some depth and breadth of coverage. So again, all of next week will be lab. All right, we've already, as I mentioned, we've already gone over the Joes. We'll talk a little bit more about the rock, paper, scissors program in just a little bit. Okay, yes. Did we not finish Joe's? Okay, then let's finish Joe's. That's cool. We'll still be fine. All right, thank you for reminding me. I think that I'm working on the same one you have, which is the class one, so. Nope. That's the one that we started with, so let's see. Okay, I believe this is it right here. Okay, so what we had gone over last time, and I appreciate that, is we were going over the stuff for Joe's. All right, I gave you the code. So if you weren't here the other day, you're going to have to go back and watch the tape. All right. And the first thing that we did was we went over 5 iterations of a calculator program, which I called, basically worst to best type of scenario, where we talked about being able to pass parameters around. So that's in there. Those 5 different projects, those are all out there in the in-class folder for last Monday, so under 316. All right. So we came in here, we created our constants because these were the costs of the different things that we were going to be doing at Joe's. And if you remember, if we look at the actual form, there's what the form looks like. So we got an oil change, a lube job, radiator flush, transmission flush, safety inspection, muffler, tire rotation. We've got our parts and labor costs, And what we had done last time was we had gotten through all of this, the oil lube, the flushes, and we went over the part stuff. And then what I mentioned to you, because we kind of ran out of time, was we'd go over the labor stuff right now, and then we'd figure out how to do this stuff. All right? So, like I said, those were our constants. Those were the variables that I'm using. Now, you could make a big case in here, and I want you to realize this, and I'm going to explain something to you that might not make a whole lot of sense. All right, but I didn't make these rules. Much of the programming that I did in this particular program is not well done. And what I mean is, everything that you see right there that's gray, what you should always strive for as a programmer is to have as few global variables as possible in a program. And if you look at right there, I've got probably 8 or 9. And that's, you really should have 0. All right, why should you? Because what you get when you have global variables is you open yourself up for what are referred to as side effects, which means that anyone in any routine can change the value of any of these variables. And that's not really a good thing. All right, and I've given this example before. It may or may not make sense, but I'll throw it at you anyway. If I go into the banner system here at Blackhawk, I can go in and I can look at all sorts of information about me. If I didn't know my pay rate, etc., I could look that up. I could change my address. I could change my dependents. I could do all that different stuff. All right, but for example, all right, I was just in talking to our the coordinator for Blackboard, Cynthia Delcourt. She's a very nice woman. She's a very good lady. But I can't go into the Blackboard and look at her stuff. All right, because it's none of my business. But even in Blackhawk, or in Blackboard rather, try it again. Even in Banner, I can look at my pay rate. I can't change it. Makes sense, right? Well, maybe it doesn't make sense to me. I should be able to change it. I'd be happy just putting a 1 before the first number they have in there. I'd be a little happier. All right, not going to happen, but you know. But the point is, these variables that you see here now, for the rest of the program on down, I can change their value any place. That's not a good thing. All right. So we went through this last time. We had our typical exit code, and you know, as things come up to me, I want to mention them to you. Do you ever see this right here that says up here where it says 1 reference? Do you ever have that? See where I've got? Basically, what happens is, and it still happens to second-year students. All right, I'm not saying that the second-year students are in this class, but it still happens to second-year students. That you come in, and you're right here, and you know, I double-click right here on the form. Now it's got private form, form Joes, load, and it's got the 1 reference. Once you do that, as far as C# is concerned, you can't remove that now. Even if you remove the associated code, it doesn't like it when you remove that. And one of the reasons for that is when I just did that, it didn't just write to this file. It wrote to a file that's in the background. It wrote to like this one, the designer, and some other stuff. That's why I had told you from the beginning of the semester that what you should be doing is putting in your components, renaming them, and then double-clicking on them. All right? Because otherwise you end up getting a bunch of garbage in there that you really don't want. I mean, is it physically possible to get rid of it and get rid? Yeah, it is. But sometimes it's really and truly not worth the work. All right? All right. And a couple of you have had situations this semester where I go and I bring up your stuff. You know, you do a good job, you save it into the H drive, but whether you realize it or not, somehow, some of your project, when you saved it to your virtual desktop, and some of it you saved to the default drive for this. Because when I come over here, and if I don't see all this stuff, sometimes I see some of the stuff in here, and it's got little warning symbols, which means that some of that file is saved to a place I can't get to. That's why when I write something down on you know, when you get the grades back, and I write something down on there and I say I couldn't open it, that's why. All right? Because you're the only one who can get to the things in your desktop, or your regular desktop or your virtual desktop. Alright, so let's just jump back in and we'll take a look at this. So what we had done last time, again, if you weren't here, just as means of really quick review, we went over the comments, we went over the variables. I said I should have really put comments for the variables, but I didn't. Our regular exit button, and notice the clear button on here. What we are told to do in our specs is when we click this clear button right here, the button that you see the mouse that's over it, you're supposed to make sure that everything that's in these two check boxes is unchecked, in these three check boxes are unchecked, these two check boxes are unchecked, these text boxes are cleared, and these text boxes are cleared. Really what you'd expect to have happen when you click a clear button. But in the past, we had done everything right there in line. That's also considered poor programming practice. All right, and I showed you why last time when I showed you, for example, those calculator programs. Because if we were to come back here and we were to add menus, let's say that we ended up with a bunch of buttons and we didn't have room anymore, so we put a bunch of menus in here. And again, if you weren't here last time, it's not hard to add a menu. Literally, you come down, one of the things that's in here is menus and toolbars. Menu strip. You take it, you drag it up there, you click. There's a menu. That's all there is to it. So if I came in here and I decided that for this menu that you see right here, I wanted to have File, and then underneath it, I wanted to have, for example, Calculate. I'm just going to keep it simple. So Calculate, Clear, and Exit. All right, that's all I did. I mean, that's literally all the time it took. And notice if I save this and run the program, there it is, and it's there. So right now, the way this program is written, this Calculate button, if I wanted it to do anything, first of all, I should rename it if I'm going to put anything there. So I'm not going to click on it or do anything with it. But I'd have to call the click event of that button, and you can do that. You can call the click event of a button from a menu. That's considered, again, poor programming practice. Think about why that's poor programming practice. What if later I decide to get rid of the button? All right. So the idea is, now with this clear routine, if I want to be able to call it either from here or from here, all right, I'm going to be much better off by modularizing from the get-go, like we're doing right here. And all this is doing is it's calling these different routines. And again, we went over this last time. Setting those checkboxes to false, then those checkboxes to false, then those checkboxes to false, and then all of our text boxes equal to the empty string. Now, by now, that should make sense to everybody in here what's going on. Because you are supposed to implement a clear button for the game that you're going to do, the rock, paper, scissors game that we'll talk about a little bit later. And that shouldn't be, a stretch for any of you to do that. In fact, I'll show you mine later again, and I've got the executable out there on the P drive, but I put two clear buttons in there. Do you want to clear just this game? Because I keep a count of how many times the computer won, how many times the human won, and how many ties there were. So I let you clear either the game or all of those counters. You can do either one. All right. Then we went into the calculate. And again, you'll notice what we're doing here is what's referred to as modularizing our code. That's exactly what we're doing in here. All right. We're calling all these routines. So if you notice, the only thing that we're doing in here, the only thing that we're doing in our calculate routine is we're calling other routines, all right, and then we're taking the result of some of those other routines and just adding some stuff, calling more routines, and then just setting stuff, calling another routine, and setting stuff. So what's happening is this calculate button is acting more like a driver, all right, and if you don't know what that is, that's the way that you typically write code, all right. You have one or more modules, methods, functions, whatever they're called, depending on the language, that drive the program. And the idea behind a driver is like a supervisor. And I've given this analogy before also. We had a supervisor that was here about 15 years ago. And I'm still really good friends with him right now. But there were times, to be honest with you, I wondered what he did. Because he walked around the campus a lot, but I didn't really ever see him doing anything. I saw him in his room a lot, in his office, but he didn't seem to be doing anything in there either. Then he got permission in the middle of the semester to go to Europe for 3 weeks. Then I realized what he did. because a lot of stuff in our department went to hell while he was gone. So it wasn't his job necessarily to do this or do that, but it was his job to delegate authority to the right persons to do what had to be done. That's what a driver does. Rather than doing the work, it delegates the authority, all right, to other routines that do the work. All right, so that's what the calculate's doing. And if we look in here, again, we talked about this last time, but in here, as I mentioned, I'm not going to go through all of these, but we'll just look at this one again. You can either have neither one of these checked, either one of these checked, or both of these checked. So the total for oil and lube can either be 0, or 26, or 18, or 44. And the same kind of way in here, and the same kind of way in there. So all we're doing in here, their OLC is just oil loop charge, and we're saying if the first one is checked, add that to your oil loop charge, so that's the constant that's 26. If that one's checked, add the 18. We're setting it equal to 0, so if neither one of these are checked, it's still 0. If just this one is checked, now it's 26. If just that one is checked, it's 18. If they're both checked, it's now 44, and then we return it. So we went over that last time. We do the same thing with our flushes. We do the same thing with our miscellaneous charges. Okay? And then we kind of were getting close on time. So we went through this, but we did it fairly quickly. All right? What we have to make sure we're doing then is now, so we've done this one, we've done this one, we've done this one. But in here, there's a couple things that we have to be leery of or know about. First of all, parts has to be a number, and parts has to be positive. Doesn't make sense that they're going to put a part in your car and they're going to pay you. It doesn't make any sense. Same kind of thing with labor. So both those things have to be checked. This thing that we put in here for labor, that is not a dollar amount. That is the number of hours of labor that all of our work is going to take. All right? And then we multiply that by 20 because the way GAT has set it up, the rate is $20 an hour. All right? And then when we get all done for our services and labor down here, that's the addition of all of these, and our labor, our hours times $20. That's what goes in here. Then our parts that we have right here, that goes in here. And only parts, for whatever reason, this is the way he did it, only parts is taxed. And it's taxed at 6%. So if I put $100 in there, there'd be 100 here, and there'd be $6 right there. All right. So I believe that if we check everything, we have $100 for parts and $10 for labor. The whole thing comes out to like $595 or something like that. All right. You can run it later and find that out for sure. So these are our labor hours. This is our labor cost, which is our labor hours times 20. And this, I believe, is, yeah, just OC, other charges. That's going to be the total of everything that we put in there. So the first thing we're doing is we're coming in, we're attempting to convert that parts thing. So I did both a try catch in here and the convert, where we're trying to parse it basically. All right. So if you can't do this, it's going to catch it as a format exception, give you a message, parts cost must be numeric and greater than 0. All right. And it's just going to basically clear that out and you'll go back. If what you put in here is negative, it doesn't make any sense. So we're doing the same thing. But notice what I tried to do is if it's negative, that's an out of range error. And if it's non-numeric, I put invalid error. I probably could have put something better there, but notice here, parts cost must be greater than or equal to 0. Parts cost must be numeric and greater than or equal to 0. All right. Then we do a, if we get down to that point, we get down to here, we put in a valid parts. In other words, it's a positive number. It could still be something that's astronomical. We could have fat fingered, instead of putting $100, we could have put $100,000, but we don't know that's illegal. All right. So we take that parts and we add it to our total charges here, and then we end up putting that, these two lines that you see in gray here, put that number here, and they put that number here. All right. Then we do a similar type of thing right here with the labor. If the labor hours are less than 0, it's out of range, okay? And If it's not numeric, it's going to be a format exception. So we're doing the same thing. Does all that make sense? Okay, so if we get down to the bottom here, if we get down to line 271 that you see right here, what that means is we had a valid number in for our parts and we had a valid number in for our labor. They were both positive. All right. So our labor is our hours that we put in times labor, which is $20 an hour. So after we figure that out, this line right here, line 272, that line figures it out and it's putting that cost. I don't remember. I think it's here, but let's take a quick look. So it says labor.text equal labor.toString. So it's text labor. So if this is text labor, that's where it's putting it. And it is. And you can look at that and say, well, that's, you put a 10 in there. Yeah, but that's not what your cost is. If you put a 10 in there, meaning your $10 worth of, or 10 hours worth of work, it's 10 times 20, so the 200 is what gets put in there. All right, and I also mentioned to you last time that I'm formatting all these for N2, numeric with 2 decimal places. All right, it'll set it up for me, but I'm not saying I could put a C there for currency. But I know if you're like me, a lot of times when you're testing, you don't like to keep putting new numbers in every place. So if you have a dollar sign in there and you click the button with a dollar sign in one of those input fields, it's going to fail because that's an illegal character. That's a non-numeric character. All right, so here's the new stuff. So here's our tax charges. Pretty simple. We set TC for tax charges equal to 0. If parts is greater than 0, then tax charge is our parts times our tax rate, which is 6%. So again, with the example that I gave you before, if I put 100 in there, and I'll come right back to it, so if I put right there, for parts, I put 100, right there, when I'm running the program, and I get down to this line. Now it's going to take that 100, multiply it by 6%. So the total of that is going to be 100, or is going to be 6. And again, hopefully that's the kind of thing that just makes sense to everybody. And guess what? Don't worry about it leaving because we don't need this. I showed you that before. This is the rest of the program. This right here adds up all those charges. That's all that's left. Now, going over that, are there any questions on anything? I'll leave it up for a couple minutes, but are there any questions on anything? Go ahead. Okay, let me answer what I think your question is. Okay, if you wanted to, okay, I'll come right back to where we just were, but I think somebody asked this question last time. It might have been Eric. It's like, why didn't we, why didn't we put these in different routines? All right, and not only we have, we should have. That would have been even more modularizing on a program. You may or may not realize this, but now we're up to almost 300 lines, and I think that's definitely the longest program we've had this semester. I could easily make this 500 lines and do a lot more modularizing. All right, so is that the question you asked? Yes, and not only could you, what some people try to do too, just so you know, is when you look at this, we've got the try-catch here and we got the try-catch here. And they're not the same thing, but yet they're very similar to one another. There as a programmer is where you have to start thinking, should I have just one function and pass the different stuff in and call, or should I have 2 of them? That's a programmatic decision. In other words, it's one the programmer makes. All right, and to be honest with you, there's, not to be funny, there's no programming police. So there's no right way or wrong way to do it. It's the way you're more comfortable with. I'll take your question a second, Micah, but with some people, the problem with just putting it in one is that people try to take it then and make it like silly putty, because then somebody else comes in with a different kind of error. Oh, I can use that one too. And pretty soon, now you've taken that one routine, and now that one routine is hundreds of lines long. And that's the problem with doing it that way. So, go ahead. All right. Well, why don't you put this stuff in, and then we'll back up to the labor try-catch. again, you don't need this load stuff that's down on the bottom. And it should make sense to you that what this is doing right here is it's taking everything that was in those first two checkboxes, adding to it what's in the second two checkboxes, adding to it what's in the third two checkboxes, adding to that what's basically in just about all of the other or the text boxes, doing our taxes, etc. All right. One of the things that I'm going to be looking for is when you're writing the game, I don't want everything in your button. Hopefully by now that makes sense to you. All right, I'm looking for you to modularize. All right, I'm giving you very few instructions other than what's in the book, and I'm doing that on purpose. It's time for you to start spreading your wings, so to speak, and doing things the way that you think they should be done. And I think that Mike will tell you, and I think Teresa will tell you, that in the second, John for sure will tell you, that in the second year, you know, a lot of times you'll just get an assignment, and it's not something out of book, it's something I made up. And people, well, what's it supposed to look like? Yep. Yeah. What does that mean? That means it's supposed to look like whatever you want it to look like. All right. I don't like to do that because then people think they have to code and make it look like something I've done. I don't like that at all. All right, I spend very little time writing these programs. This one was a little longer because I actually wrote this one the way that it should be written. In other words, not the way that I'm showing it to you. I wrote a little bit of code. You know, I created my interface, wrote a little bit of code, and tested it. Make sure that worked. So in other words, and I'll come right back to it, I created the interface. Then after I created the interface, all right, I went in and just did the code for this. Checked it and made sure it worked. All right. And then I did the same, added that code, then added that code, then added that code. By that time, I was pretty doggone sure that by the time I got down to the bottom, it was going to work when I got down to the last couple functions that I had. That's how you should be coding. Creating the entire interface in mass, that's fine. Renaming all your stuff in mass, that's fine. But you shouldn't sit there if you've got 200 or 300 lines of code. It would have been wrong to write this entire program and not test it along the way. All right? It's just silly to do that. But compilers have gotten so complex and so smart. All I know that if I haven't run this program once yet, all I know is when I run it, I don't have any errors because there's no squiggly lines. And down here where I'd have my errors, nothing is showing. All right? That's all I know. All right, I'm hearing very little typing, so my hope is everybody who needs that stuff has that stuff. And Micah said that I didn't put the other try-catch up, so let's put that up. That's going to take a second because it's a little longer. So it starts here. Let me widen this out a little. All right, so I'll put that up. This is the second try-catch, so it's right under the first one, where I think that you had this from last time. All right. So I'll put it right there, and I'll leave that up for a couple minutes also. Does it make sense to people that when you are writing these methods, okay, and sorry, I'm just going to move this up for a second, but I'll move it back down. Does this make sense to people looking at this? This says, what this means right here, this. Public means that it can not only be called from within this class, but if I wrote another program with another class in it, it could also call this method because it's public. It's available to all. This means that there must be a return statement in there, and the type that's being returned must be a double. This is just the name, and this means that this particular routine requires no parameters. If I did not have a return statement in here, I'd have to change that from double to void. Does that make sense to everybody? And when you look back up at these, all those clears, they were all void. Now these are private, and the difference is our public routine. We got another private one in here, but you can have private, you can have public. We're going to get into that more at the end of the semester. So if that really confuses the heck out of you, like I said, we are going to talk about it before the semester ends. Where is that? There's the first try catch, and there's the second. But they do talk about that at the beginning of the chapter. They start to get into the whole talk about modularization, and they call modularization divide and conquer. What I've used for an example, I don't know if you remember this, but I do like 4th or 5th grade. First time I had to do a book report, and our teacher told us when we did the book report that she wanted an outline. And you went from Roman numerals and you went from real specific stuff or general stuff to real specific stuff. That's what we're doing. Tell you what, I'll give you about 5 minutes, and then I will move that down. So hopefully within 5 minutes you can do all the try stuff, and then I'll move it down so the catch is on the top, so then everybody can see what all is left. That stuff? Yes, you're right. You're right. We'll look at that next. Thank you. Just about every time I teach this class, at least there's a lot of similarity, but there are differences too. And I know the next time that I teach it, for instance, one of the things I'm going to do is not the first program, but one of the first programs, I'm going to pair people up. And one person's going to write the code, and the other person's going to have to take what the first person did and write all the comments, and is going to have to explain what the person did without asking the person anything. Because I've had that happen already, where I've had two people working on a project, and one of them, for lack of better words, bailed partway through, and that person did most of the code. Now the other person is taking over, and they're trying to figure out what the first person did, but they can't, and they have a hard time getting a hold of that person. That's kind of real life. Somebody's working at a company and they leave the company, and somebody else takes over, and if the thing is not well documented, does everybody have this stuff done here? All this stuff in the try? Yes? No. There's a return here. We're not there yet. There's still stuff we have to add. Because if you're there, if you haven't put this stuff in, there's a return there, and there's a return here. All right, so here's the rest of that. So the rest of this routine is in here. That's I'll remove it the gray in just a second, but that's the rest of the routine. So I'll give you till about 1:45, and then I'll mouse back up to the calculate so you can put that in. Then we'll take a break. of this is in the other or miscellaneous. Yeah. And I think that's part of the reason that Luke asked the question, well, couldn't you have taken this and broken this down into more routines? Because then it would have taken that routine and made it smaller. All right, and again, yes, it could have and should have been. Erica is going to tell you, remember in Java the other day how a bunch of those routines I just put a return zero type of thing in there? I think they did it in here too. That's why I did that, so you didn't get those errors. But since we hadn't keyed that stuff in yet, we removed the stuff that was there. That's why you were getting the errors that you were getting. Now I'm going to come right back to it, but if you take a look up on the screen for a second, everybody, we now have all of this code. We've got all of this code, all of this code, all of this code, all of this code. We've got our exit, we've got our clear, but we'll have to go back and make some changes, as Eric said, because what I did was I left the calculate code out, most of it out. All right, that's why right now if you run this, it's not going to do very much because we're not directly calling most of the routines that are in here. Okay, everybody see this too, just so you're aware of this. You are able to go in and change the color a little bit on this stuff, but you notice how this looks right now. It for lack of better words, it kind of looks ugly. It's hard for you to see this, etc. So what I would probably do would be to highlight all of this, and right now it's probably locked, knowing me. Yeah, maybe it's not. That would be good if it's not. And then, whoops, not that. And then move it down. Now it doesn't look nearly as bad. But again, there is some stuff that you can do with this as far as prettying it up, so to speak. All right. Somewhere in there is locked, but it's not showing it to me, so I wanted to lock that, but I'll worry about it later. Now, does everybody have that typed in, or a couple of you sound like you're still typing, and that's fine. said, the most important parts of the chapter we've already gone over. Our midterm grades are due today. And everybody got an S. Made it much easier. I hate giving U's anyway, so I just gave everybody an S. Oh boy. I'm trying to figure out a way in Banner because it doesn't let you put an S in and copy it. You've got to do the drop down for everybody. And I'm trying to figure out a way to get around that. I put my own hacks in. In the old Banner, I figure out a way to do it, but it doesn't work in the new Banner. Then it was fun because then I could do grades in less than a minute. Now again, I want you to know that you're keying this in, and let's say you get it all done, and you go to run it later, or you don't run it all, but you run it before you turn it in, it doesn't work. Then come up and ask me, or ask John. Okay. One of the things I was working with one of the second year students yesterday, and she's working on a project for the school, and she's doing it as part of like an internship. But I do want you to, if you don't look up on the screen here, because I wish that Gaddis did a better job in this, and he doesn't, and I probably should. But you can go out and find a lot of things online. Did you ever notice here where it says debug? That if you look, there's a lot of stuff there. All right. So if I'm running my program and I want to see what happens before I return this value, I want to be able to check it or whatever, I can take my mouse and click over here, and that now has created what's called a breakpoint right there. So when I run the program, when it gets to that point, it's going to stop. And then what I can do is I can take my mouse and put it over anything that's above this, and it'll show me the value. All right. Plus what it does, it'll open up a window down here in our error area. It's called a watch window, and it'll show you everything that you've done so far, and that's nice. There are also some buttons, so you just remove it by clicking it again. But there are some buttons up here also. There's a thing called step over, and there's a thing called step out. There's a whole debug toolbar. It doesn't show right now. If I right mouse click on here, what is it? It is on here? It's on here. But there's a way to add it to here also. This is the only toolbar I'm showing right now is this one. But I think if I go to view toolbars, that one of the ones in here is the debug toolbar. If I click there, now I've added a bunch of other stuff to do debugging. And what I can do, among other things, is I can do a step into and a step over. If I do step into, I can run my code a line at a time. Literally. John will tell you, because we were working with Laura yesterday, that can literally, you don't realize, because it shows you all those files in the background that you don't see. Laura gave up after probably about 300 lines. She just kept hitting F11, 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 F11. And she was getting, is it fair to say she was getting a bit frustrated? Yeah. But you can do that. Sometimes that's what you have to do. All right. Or you can set a breakpoint, and once you get to that breakpoint, you can start hitting F11, and then run it a line at a time from that point. All right. And Microsoft, under the MSDN, has got some good information out there about debugging and doing debugging inside of Visual Studio. Better than what I just gave you. But I wish that Gaddis did a little better job of talking about that. So I hope now that everybody's got that done. So I'm going to come back then. And this is the calculate routine. That's the whole thing. So you probably don't have all that. So I'll leave that up there. All right, I'll leave it up there till about 9. So those of you who are quick can type it in 2 or 3 minutes and go out and have your cigarette or whatever. And those of you who type a little slower, you're going to get very little break today. But we'll probably still be done with the lecture part around 9:30 or so. So I'll start it up again at 9 o'clock. All right? I'm going to stop this for just a second so I can stop taping. It'll come back, but it'll take about 30 seconds.